With that, we're going to start the faculty presentations this morning. We have 3 faculty presentations. The first up is Dr. Raoul Boughton, and he is an assistant professor and rangeland scientist. His research focus is range management, invasive species, and coyote conflict. Dr. Boughton's extension focus has been to promote environmental stewardship by educating ranchers and state landowners about the importance of their lands and landscape connectivity to the persistence of wildlife, as well as to supply information on how best to encourage wildlife and promote conservation efforts on Florida ranches. Dr. Boughton?
Well, thank you, Lauren, and good morning, everybody. And I want to follow up with something that Matt just mentioned, and that was heritage. And if any of you have not looked at the title of the talk that I'm giving, it is Using Fire. How much does it influence cattle grazing behavior? So when you talk about heritage here, and your heritage especially, when people started to graze here, how much did they use fire? All the time. Before that, how much fire was on this landscape? Anybody know? A lot, an awful lot. And actually, we've done cores of trees, and this was done on Avon Park Bombing Range, great place. They did a long-term study, and they cored a whole lot of longleaf pine out there. And they were showing that fire in those landscapes was every 2 to 3 years on average. And those trees were back to 300 years old. So that's a lot of fire on our landscape. So what's happening now? Are we able to burn as much as we want? Most people can't. We've got a lot of urban people that are encroaching on agricultural or wilderness land, so it's becoming hard for smoke issues. We have legacies where we haven't put fire on landscapes for maybe 100 years now. So actually getting fire to actually go through some of those landscapes is really hard. When we do get a fire going, it can be horrific because there's a lot of load there. But fire is one of those tools that's really important for our landscape, especially to maintain the native vegetation. But it's not by itself. The other thing that maintains native vegetation in these types of landscapes, and I'm talking about grasslands, is grazing. Okay? So if we take grazing off our land, what happens? You would have seen this. You leave a field fallow for long enough, pasture fallow, you get woody encroachment, you get in this environment, you get a lot of palmetto, you start getting wax myrtle, you get all sorts of things start to move in, a lot more pine can survive, you take fire off as well, and suddenly you've got a forest, and an oak forest. So I'm going to start my talk now. Let's give you an introduction of what I'm thinking about. And this talk is about how cattle respond to fire. So I've read a fair bit about how cattle supposedly respond to fire, and do you know how much research has actually been done on what cattle do in terms of grazing behaviour in fire? Almost none. There's been really, really simple studies. So we decided, let's do a complex study. Let's try and actually get real data to show if you put fire on the landscape, what happens to cattle grazing behaviour. And we'll start here. So around the world, there's about 40% of our terrestrial landscape is grasslands. But grasslands are really threatened. About 25% of those grasslands are used for livestock industry. So this is a worldwide phenomenon. In the subtropical grasslands, we have about 8 million, and you'll see this in there. That is not meters squared. That's supposed to be miles square. For some reason, that became a little m. It should be a big M. So 8 million miles square of grasslands. And so that's tropical and subtropical grasslands. And that's about 13.5% of the world's land surface area. They happen to be some of our best grazing lands too. And so they produce a lot of cattle from those areas. They also happen to be commonplace where we have fire. So they're globally, not just here, they're globally important for economic productivity, really food security, and my real interest in this is biodiversity. How can we manage cattle, keep cattle on the landscape, but keep our wildlife communities strong too? And that's really important to me. I don't want to see our wildlife disappear, and that has happened in many places. And we want to keep those populations sound. I mean, you think about some of the things that we're suffering from now in terms of wildlife. Bobwhite quail populations are declining. or have declined a lot. And most of those declines are in areas where grasslands are not getting fire. And so fires are really important for that species. Anyway, so fire and livestock are both disturbances. They change the habitat. They change the way grasslands actually operate. And they keep it as a grassland. So that disturbance changes structure, keeps weedy vegetation down, maintains biodiversity, and it actually works best in native grassland systems. So when we have a complete monoculture of grass, which is important for hay crops, you don't want to fire in there, but some of these other grassland systems, we really do need fire. And so one way we decided to actually look at this was measuring cattle movement. And we do that with GPS locators. And I'll skip over a tiny bit. If you look at page 12 and figure 2, you can actually see some of the GPS units we've actually built in-house here and put on cattle. This study required about 35 to 40 units to actually put on cows. For us to do that with commercially made GPS units, it would have been about $100,000. It's way too expensive for this type of study. And so we ended up building them for about $100, and it gave us really good data. And you'll see that in a minute. So we put GPS units on these cattle, and then what we did is we set up an experiment that was funded federally through the National Institute of Food and Agriculture. And we were asking, do cattle behave differently when you provide them with a patch burnt grazing system? So in this case, we're burning one area and leaving 2 areas that they can choose to be in as unburnt, sorry. And so they have 1 burnt area and 2 areas that are not burnt in. And then our other treatment is typically what we would do here, and that's actually burn a whole area flat out. And that may happen every 2 or 3 years. So you're giving cattle choice in this case. And why is choice important? Because if you can give them choice and you change their behaviour, we're actually changing the intensity that they use the landscape. And there's a couple of really positive things from that. Can you actually get cattle to stay in an area and graze for longer? And I'm sure every rancher out here understands why that's important, because you can actually get a lot of areas staying in grass. You can create a grazing lawn. They keep coming back once you get that grazing lawn going. Okay? For another part of it, you've concentrated the cattle in that location, but not the other 2. So they're actually growing a little different, and they're creating a structural heterogeneity. That structure is really important for grassland birds, for deer to forage on, for all sorts of other species as well, and even plant biodiversity. So this study was set up at the Buck Island Ranch, and if you look at figure 1 on page 11, that's the ranch, and you can see in blue, they're repeated plots. So it's a fully repeatable design, and there's 8 of them. The dark green in the middle is actually improved. It's sort of Bahia-dominated pastures. The more yellow on the side is more semi-native pastures, and we split that. So we have a lot of repeated plots here with a lot of data coming in. And what I wanted to do specifically was ask the question, what do the cattle actually do when you actually put in a patch burn grazing system? Will they use that fire burnt area more in terms of time spent, grazing time spent in there? And the second part of it is, will they distribute their grazing more evenly? So do they actually graze more of it rather than being clumped grazing? And one of the purposes of ranching in terms of getting to your grass is actually getting more even take of that grass. And so can fire actually do that? And we measured those 2 things quantitatively, not just subjectively. We quantitatively measured them. So through those 16 pastures, we put out 32 GPS units. And those 32 GPS units actually collected 1.9 million locations for cattle. So you can think about that. Every GPS unit is collecting information. It's 1.9 million points. Where a cow is doesn't tell us what behaviour it's actually doing, though. So how do we get at behaviour? I'm not going to watch cow for a whole year. I'm not going to watch 32 cows for a whole year and measure what they're doing every minute of the day. It's been done sort of before, but I'm not doing that. So what we do is we actually use speed of movement. And so with GPS, you actually know where it was and where it's going to, and you can measure velocity between them. So you're measuring speed of movement. When they're stationary, there is no speed. They're resting. Okay? When they're moving at a very slow pace and actually moving backwards and forwards, they're often grazing. And over a certain speed, they're walking, of course. And so we did that, and and this has been quantified. We watched a few cows to actually quantify that. If you look at figure 3 on page 12, you can see when you break out those behaviours how much cows are actually grazing, resting, and travelling for all of those basically 2 million GPS points. And about 55% of the time, cattle are grazing. Did you know that? It's very interesting. So they do actually graze quite a lot. And this matches several other studies around the world that have done this sort of thing as well. I point this out because I'm interested in grazing. I'm not interested in resting, and we're not interested in travelling. We're interested in that grazing period only. And so from now on, all we're talking about is grazing activity of the actual cows. And I'm going to skip you to, you love graphs, don't you? Yeah, come on. So I'm going to skip you on to page 13. I had to have a visual for this. I couldn't not show you these things. So page 13, the top page, which you can see a red and black actual dots with, and that the bar around it is variance, is how often cattle will spend time, grazing time, in the patch burn compared to the non-burnt areas. That black line that you can see going horizontally through that graph is if everything was even. That's where it would be. So if they spent the same amount of time in every third of a patch of that patch burn grazing system, it'd be 33% of the time. You can see there's a line on the left-hand side that says burn date, and that's exactly when we put the burn in, and the cattle were in those pastures basically when the burn was done, because we only burn a third of it. And you can, at that time point, you can see the black points, the unburnt pasture points, are preferred. Of course, because you've just turned it into black, okay? There's just soot on the ground, dust, no grass growing at all. They might go over there to eat some charcoal, but that's about it. They spend quite a lot more time in the non-burnt area for about a week. After that week, you can see they switch almost immediately, and within 2 to 3 weeks, their amount of time that they're actually spending on that burnt area is almost double what they're spending in the actual unburnt areas. So they're attracted, and you all know this, they're attracted to green pick, they go there. That's great, but how long does it last for? So how long does the effect of being attracted to a burnt area actually last for in your pasture or paddock system? And then if you go across this graph on the bottom is January 2017, and you'll see April, July, October, and January. In all of those grazing bouts in there, each one of those groups of dots, you can see even right to the very last group of information, which is in December, those cattle are still attracted to that grazed, burnt patch first, and actually spend more time in there on total. So a year after you're putting that fire in there, cattle are still going there. So we've set up a repeated use of that site, and they're always preferring to be there. They graze in that site. What's interesting, I know of one other study that looked at some of this sort of thing out west on burnt site, and they measured some activity by cattle, and they showed that cows there would spend more time or preferentially go to burnt treatments for up to 3 years after that burn. The cows know where the good grass is. They'll keep going there. So burning, in this case, is actually attracting cows to the site. They're spending more time there. They're grazing almost double the amount of time. But are they doing it in clumped? Are they going back to same little clumps? Or are they actually moving their grazing and making it more distributed? All right? So that's the next question. Oh, I should say, by the way, the graph below is when you actually put in burn the whole lot. We wait a month and we put the cows in there. There's no distribution. They choose where to be all the time. There's no choice in that case, which is a given. Now, if you go to page 14, this is a harder graph to understand. But we'll make it easy. The burnt patch is in red. All right. The Y axis on this graph is actually called an index of dispersion. You don't worry what that means, but basically it means when it's very, very low, your grazing is distributed more equally across the whole pasture. So if I say that, what can you see happening with that burn patch? Is that they're grazing a lot more distributed and a lot more evenly across that burnt area, and that's lasting almost all the way through to week 40. So 40 weeks after that burn, they're still going back there and they're actually more evenly grazing through that whole area compared to unburnt spots. What that means in those unburnt spots is they're going to very specific areas and they're clumping their grazing. So now you've actually used cattle to actually change the habitat. So you've actually shifted your habitat to more grasses and hopefully maintaining those grasses. So this is using fire as a tool, and it's a really important tool to actually keep using. And I know it's really hard to actually do this in Florida, but I think it's something we need to keep fighting for. And it's some of these laws about smoke ordinances and not being able to burn. I mean, they're getting to the point where they're restricting people's ability to manage their land. And this is really, really an important and relatively cheap tool to increase efficiency of grazing in a landscape. So we had all that information, and the last question we asked was, when are they grazing? People ask me this all the time, actually. When are cattle grazing in Florida? And so we could actually do that. And the last two graphs here are the same. They're on page 15, the same setup. There's actually the patch burn system is on the top and the full burn system is on the bottom. There's actually no difference in the timing of grazing between those two treatments. Cattle still graze the same way, but what ends up happening is there's obviously a big seasonal effect, and I thought I'd show you that here. So if you follow that red line in both of those graphs, what you find is that grazing increases about starting at actually 5 a.m. in the dry, cool period of time. So this is the dry, cool coming into winter. And so when they can do that, they preferentially graze before 10 o'clock, and they're out grazing for a long time. And if you follow that red line all the way through to hour 20 of the day, overnight, they're actually not grazing at all. And that's in the cool, dry period of time. When you come into the summer, so that's the green line, wet, warm, or the blue line, which is sort of wet, cool, that's sort of in the beginning of the wet season, the end of the wet season, you'll find that early morning grazing is retarded, and that grazing during the day is actually less in general. And it looks like they don't get their fill because they actually then try and come back and graze again more in the afternoon. And that grazing overnight starts to occur. And so cattle cannot actually graze enough during the day to actually fill themselves or keep their boluses running. So they're actually grazing at night more. And so it reflects what goes on here in the environment quite well, is that our really hot Florida sun does cause heat stress and is impacting the typical grazing time of cattle. It's something to think about. So you probably do need to try and alleviate that heat stress in some way. either shade or water, of course. And most people know that, but here's quantifiable data showing that grazing changes based on time of year as well. Not based on burn, though. They do the same thing. It's all temperature and season driven. So to round all of that out, if you go to page 10, and there's a section that just says conclusions, so you can ignore all the rest that I wrote. If you read this little paragraph, you'll get the take-home message. So cattle spend approximately 60% of their time grazing in a 24-hour period. It's a little less than that. Fire changes that grazing behaviour, and through this study you conclude that fire conducted on a patch burn system attracts cattle. That increases both the intensity of grazing there, so cattle spend a lot more time grazing in those sites. By default, it's reducing grazing in the unburned patches, and so those plants and materials there can actually grow and the structure changes. So that changes the heterogeneity of your sort of bigger system. The effect persists for a year at least. It could go on for longer, and we actually have more data. This is the first year, but it's been actually collected over 3 years. The burning promotes more even grazing. That's one of the most important things, and first times it's been really shown with this data, is that putting that fire on there, you get more even distributed grazing across that landscape. I believe that when you actually have that more even grazing and more intensity grazing, you're setting up grazing lawns. So you're now getting that repeated return visit because you've changed how those grasses are actually responding to that grazing pressure as well. And that's especially true if you rotate your cattle. The effect of the actual evenness or distribution of grazing seems to decline before the intensity of use. So even though they're going back to that burnt area, they're slowly becoming more and more clumped in their grazing behaviour over time. So that effect is slowly dwindling throughout the year. And you can see that on the graphs if you look at it. And the last thing is that these really hot summers, the subtropics, they impact your daily grazing behaviour. And that may decrease some of our forage intake during these extreme seasons. And it may be one of the reasons we have problems keeping weight on cattle at times too, because they just don't have enough time to actually get all the food they need without being stressed. So if anybody wants to come and build GPS collars with me, you can. So this study was hard to do in lots of ways, and I wanted to thank both Dr. Britt Smith, who's a main author on this. He actually managed the data. I mean, it's actually 3 years of data. It's about 6 million records. You start to manage 6 million records, try and actually analyse it, it's quite difficult. So he created brilliant databases to do that. And then the Buck Island Ranch as well, and actually my wife, Elizabeth, or Betsy Boughton, you may know, who helped set up this study, because this is one part of the study, but they're actually measuring a whole series of other ecosystem services changes with that. So they're looking at grass growth, they're looking at biodiversity, species, plants under those patch burn grazing systems, as well as carbon sequestration. So if you've got any questions, I'm done. So, all right. Thank you.